Welcome to the Connect with TrueSight webinar series. During today's webinar, you'll be able to ask questions of our panelists. The questions and answers, along with today's webinar recording, will be published to the YouTube channel a week from today's broadcast date. Today's topic is TSOM Troubleshooting Infrastructure Policies, and Shweta will take us through this content. I'll turn it over to you now, Shweta.
Thanks, Greg. Hello, everyone. As mentioned, I'm Shweta Agarwal, a Senior Technical Support Analyst working within customer support. Working in customer support, we see a lot of different types of issues, and some of these are in the area of infrastructure policies not being applied on petrol agents. These can be related to the monitoring policy configuration issues or performance issues, or could be KM configuration issues, and on occasion, network issues between the components. This webinar is for all who are using TrueSight Operations Management for infrastructure monitoring using petrol agents. In this webinar, we will be looking at troubleshooting infrastructure policies from TrueSight Presentation Server, that is TSPS. We will look at the architecture and flow between the components when the monitoring policy is being pushed from TSPS to petrol agents. Further ahead, we will look at few configuration that one needs to take care while creating the infrastructure policies. Then we will look at what debugs can be enabled for getting some detailed information in the logs. And we will discuss few snippets of a working flow in the logs. We will also discuss on few common issues and best practices that one can refer to avoid similar related issues in your environment. For those that are new to TrueSight Operations Management, that is TSOM, or you just need a refresher, TSOM includes TrueSight Presentation Server, that is TSPS, and TrueSight Infrastructure Management Server, that is TSIM. The TrueSight Presentation Server hosts the web-based TrueSight console that functions and consumes data from various TrueSight products to provide a consolidated set of view for monitoring the infrastructure and data presentation. TrueSight Presentation Console, also called as TrueSight Console, is used for administering and configuring the petrol agents. This supports integrations to other products like TrueSight Capacity Optimization, NTUT, ITDA, etc. It also supports high availability and disaster recovery. It also provides TrueSight Web Service API that enables developers to integrate the data from the TrueSight Presentation Server with external applications. Other component TrueSight Infrastructure Management Server, that is TSIM, it combines a number of things such as event management, service impact management, performance monitoring, and data analytics. TSPS is fed with data and events from TSIM, and it provides a console for monitoring and administering the infrastructure. Petrol Agent does the data collection locally and remotely and sends it to TSIM, which is then fed to TSPS. Here is an architecture slide that explains how the performance data flow between the components, and we will also discuss how the configuration information flow between these components. The flow of the performance data starts from the bottom below in this diagram, where you see petrol agents. It monitors the infrastructure according to the instructions provided by loaded petrol monitoring solutions, also known as knowledge modules, that is its KMs. Petrol agent send this collected data to TSIM server via integration service, and this is then fed to TSPS server from TSIM. The configuring and administering of the infrastructure flow from top to bottom. Configuring and administrating infrastructure happens from the TrueSight console hosted on TSPS server, and it then pushes the configuration to petrol agents and its KMs. In this webinar, we will concentrate only on the flow of configuration between these components. Here we can see this is a similar diagram seen in the previous slide. However, this has a subcomponent CMA on TSPS server. Configuring infrastructure policies on TrueSight console is managed by this component called CMA, that is Central Monitoring Administration. CMA allows the administrators to deploy configurations on petrol agents and its KMs in an automated way using this infrastructure policies. For a petrol agent to monitor a system, it needs instructions and information about what to monitor, how and when to generate an alert or event, and where to send the data and events. Solution administrators and tenant administrators configure these instructions and information in policies. A policy is applied to the petrol agents based on the conditions such as agent name, agent port, version, agent tag, and so on. If a petrol agent matches the conditions defined in multiple policies, then the configuration across the policies are applied to the petrol agent. There are three different types of policies that can be configured and applied on petrol agents. Let's just understand the three types quickly. First is the monitoring policy. This policy is used to define and configure monitoring and apply them to selected petrol agents. For example, configuring monitoring solutions on petrol agents, then creating thresholds on infrastructure management servers can be done from this policy. Then another policy is blackout policy. This can be configured by the administrators to stop a petrol agent from performing certain actions such as stopping data collection, event generation, or recovery actions. This policy is applied to petrol agents and it does not apply to the behavior of the infrastructure management server. However, if petrol agent itself is moved and blacked out by this policy, then it would not forward the performance data to TSOM as itself is not collecting data for the blackout period. To configure this policy, you must define the blackout time frame for which you want the policy to be applicable. Third policy is staging policy. You can use this policy to configure a petrol agent to communicate with the infrastructure management server by using a specified integration service. When a package is deployed and installed, the petrol agent checks in through the staging integration service. The staging integration service provides a single point in the environment where all newly deployed petrol agents can register into the solution stack. When the petrol agent checks in, the presentation server evaluates the agent selection criteria in a policy, that is staging policy, and uses that data to automatically assign a data collection integration service to the petrol agent. All these policies that we discussed provides the instructions as what needs to be done based on the type of policy and its configuration information to the petrol agents. Let's now look at some of the features with infrastructure policies. These features here are segregated based on if the configuration is pushed on the petrol agents or on TSOM server. From infrastructure policies, you can configure the petrol agent and its monitoring solutions. Then agent thresholds can be configured on petrol agents, which would enable them to generate the petrol events. Administrators can push the blackout configuration on complete petrol agents or specific monitor type or instance on a petrol agent from this policy. Then it also allows creating staging policies as we discussed earlier. All this configuration is being pushed on the petrol agent. Now for the TSOM server, you can find the server thresholds on specific instances that can be configured. From 11.304, TSOM console being deprecated, functionality has been moved to TSPS console. Also, one can create dynamic groups from the monitoring policy for specific devices or monitors. These configurations are applied on TSOM server. Whenever you modify a policy that is enabled, all the changes are automatically pushed again to the petrol agents or TSIM, even if it was applied earlier. Now, as we have a complete understanding of the infrastructure policies, let's understand and discuss some key configurations in the policies that can help us configure the policy as per recommended way and avoid any known issues during deploying and administering of the infrastructure. For any infrastructure policies to be applied on petrol agent, you need to be sure that the monitoring solution, that is KM, is deployed on the petrol agent. If not, as an administrator, you can select the monitor installation components such as petrol agent and monitoring solutions, or just the monitoring solution to create a deployable package. The components can then be installed together using the deployable package. You can reuse these packages or deploy the packages to multiple monitoring servers. We will now have a look at demo to view and verify the repository has the monitoring solution or not. This is a TrueSight console where the monitoring solutions are imported in the form of repository. Under Administration, Repository, and then you click on Installation Components tab, we can see and verify all monitoring solutions have been imported on TSPS. Now, for an example, you are installing WebSphere KM configuration from monitoring policy. You need to have extended repository imported on TSPS. As well as the same monitoring solution should be deployed on petrol agent before you push the monitoring policy configuration on that petrol agent. To get the latest version of monitoring solutions, you need to download the latest repository from EPD and import it on TSPS. There are few predefined deployable packages that are available in TrueSight console under Deployable Packages tab. You will get this predefined packages if you import the repository with the option to get the predefined packages and policies. You can find the predefined packages for AIX, Linux, Solaris, Windows platform, which contains the petrol agent package and its respective OS monitoring solution. Now, once the package is created, this can be deployed on petrol agent so that it is ready for monitoring policy to be configured. Just like predefined packages are available, there are also predefined monitoring policies that act as templates that enable you to quickly add monitoring capabilities in TrueSight Presentation Server and TrueSight Infrastructure Management Server. To use these predefined monitoring policies, you need to import them from the base or extended repository, make copies of the policies that you want to use, and then provide the configuration details for new monitoring policies to work. This concludes the demo for monitoring solution packages. Alright, coming back to other key configurations, let's see and understand staging policy and its importance in this slide. The staging policy is useful in the large environments where BMC petrol agents are needed to be distributed among multiple integration services to avoid overloading a single integration service. Using the staging policies, administrators can set only one staging ISN for all of the new BMC petrol agents while creating a package. These helps the administrators to avoid managing multiple BMC petrol agent packages. You can then define a staging policy to redirect a range or set of agents to a new integration service. Now, staging policies allow you to automate the assignment of petrol agents to the integration service nodes as the agents are first brought online. Now, important thing to note is petrol agents do not forward data or events to the infrastructure management server when connected to a staging integration service. Also, petrol agents do not activate any monitoring or blackout policies when they connect to a staging integration service until the staging policy is applied. Agents need to connect to a data collection integration service and receive a monitoring policy for the data to flow from petrol agents to the infrastructure management server. Another key configuration which plays an important role in infrastructure policies is policy precedence. Let's talk about more on this in detail now. Policy precedence controls the configuration applied to the petrol agents and the infrastructure management servers when there are conflicting or overlapping configurations defined between two or more policies. If two policies attempt to manage any same configuration as either same configuration variable or same monitor configuration, then petrol agent resolves the conflict by evaluating the precedence of the involved policies. If there is a conflict, the standard policy precedence is used, that is, lower the precedence number, higher the priority. Let's discuss some use cases for understanding how the policy precedence works. If, for an example, you are applying same configuration variable from two different policies A and B, and this configuration variable has different value in both policies, then the policy with lower precedence will get applied and the value of the configuration variable will be set as per defined in the policy having lower precedence. Another use case could be, let's consider a scenario of having two different policies having same precedence. In such a scenario, if policy with the same precedence value have different threshold settings for the same KM parameters and they apply to different platforms, then the policy with the latest timestamp is applied. So do not use the same precedence values for different policies having same KM parameters. While using Windows monitoring services via policy is an exception where the policies will be merged, as service-based policies use the include and exclude criteria rather than the policy precedence. Before you start the deployment for any infrastructure, you should define precedence numbering system or some guidelines that can be followed in your environment while creating any policy. This chart shown is as an example. This is also present in the policy precedence best practice document that can be referred. While configuring these policies, you can assign precedence numbers starting with the highest number in the range and then continue assignment in the descending order. By doing so, you can leave the lower numbers in the range for specific use cases as shown in the chart as well. Whenever possible, merge similar policies. For example, merge the policies with no conflicts. To easily track the configurations that are applied to petrol agents and to know the order in which the precedence is being applied, BMC recommends that you organize the policies according to the precedence numbers when creating and editing policies. You can have some policy naming guidelines that you can write and follow. You can use the precedence number as shown as an example, starting with every policy name. You can also have some sorting based on monitoring solutions in policy names. This would make it easier for anyone to go through the policy name and understand the configuration that it pushes to TSOM or petrol agents. Now let's see how this configuration is stored in petrol agent. pconfig utility with +get can be used to retrieve the configuration on any petrol agents. This information can be pulled from directly running pconfig +get on the petrol agent or from TSPS agent query tool as well, which can be accessed from TrueSight console. We will see this in further demo how we can use the agent query tool and read the configuration variables. Petrol agent configuration that is local to the agent would be under agent setup branch. As we can see an example here, for integration services and deny CFG falls under agent setup branch. Any configuration data would be under /config data branch, like preloaded KM, Forward events to IS falls under config data branch. Other branches are created by policies based on the monitoring data. For example, PMG branch is for log monitoring, PSX is for Windows servers monitoring, and so on. For the configuration under config data, only the difference between the configuration received and the configuration that the agent contains is applied. If some configuration is not received for a particular class, it is considered to be deleted and is deleted from config data on patrol agent. Then for agent setup configurations, the variables under config data pconfig branch take precedence if there are conflicts. Let's talk about tags that can be used for grouping of the similar types of patrol agents that administrators can decide based on its monitoring solutions. These tags can then be further used in the infrastructure policy so that the same policy configuration can be applied on all the patrol agents having the same tag from a single policy. In case of this tag is missing on any of the patrol agent from that grouping for some reason, then the policy configuration will not be pushed on that patrol agent as it does not have the tag itself. One can review the patrol agent configuration using pconfig utility or agent query tool to verify if tag configuration variable is configured or not. In case if it's missing, then you would want to push this tag using pconfig utility on patrol agent. We do not recommend to use this in configuration variable from a monitoring policy, as if policy is disabled, then the tag will be removed from that patrol agent. There are documents and knowledge article available that talks about it in detail and provides steps to push the tags on patrol agents. Now, once the infrastructure policy is created and enabled, administrators should verify if the policy is being applied or not. Only if the policy is applied, then this configuration information will be pushed to patrol agents or the TSOM server. If there is a failure in the policy to be applied, then we will see further ahead how we can troubleshoot and analyze it further. To first understand if the policy has been applied on patrol agent or not, there are few methods or steps to verify the same. You can verify this either from TrueSight console, or you can also verify it from the patrol agents directly. Let's have a look at the demo to see how we can verify if the monitoring policy is applied or not. From the TrueSight console, soon after saving the infrastructure policy, you can click on the action menu of the policy and click on View Applicable Agents. This will show you the list of patrol agents on which the policy was applied. If you don't find your patrol agent here, then you need to edit the policy and verify the agent selection criteria to understand if that matches with your patrol agent or not. Another method is to go to the Manage Devices under Configuration and search for the patrol agent that you wish to verify the policy status. On the right side of the same patrol agent, you will see your policy status. Mouse over on this status icon, that is the icon tooltip, and it will display more details and message explaining if the policy was successfully applied or it failed. As we can see here, the tooltip provides the list of the infrastructure policies that were applied. If there is a failure, you will see a message as the following policies were not applied, followed by the policy names. The policy status icons here itself are self-descriptive. The blue icon with I specifies information message. This policy status icon can be displayed when there is no information from the integration service about policy applied status. One of the reasons for this policy status icon could be when you upgrade, this would be the initial policy application status for all patrol agents, because there is no information about whether the policies were applied or not. Another reason is that the petrol agent is not being policy managed. As you can see from here, we can see the agent is currently not managed by policies. This is decided by a configuration variable deny CFG. Deny CFG decides if the petrol agent can be configured from TSPS CMA or not. If the value for deny CFG is false, it means TSPS CMA is allowed to configure the respective petrol agent. If the value is true, it means petrol is not managed by CMA. You can also find a blue question mark icon under policy status. That means there is no response from the petrol agent or from the integration service about policy applied status. You can see a red cross icon in case if one or more policies fail to apply. Now, from this same place under Manage Devices, there is another way to verify the infrastructure policies were applied on the petrol agent or not. Once you find your petrol agent and click on the action menu on that petrol agent, we have an option of Show History for Applied Configurations. Here you can see all the policies and configuration that was pushed on the petrol agent with the timestamp details. It also tells you what configuration has been pushed from the policies that were applied on the petrol agent. From this same agent query tool, we can click on Query Petrol Agent and verify some more configurations with respect to the petrol agent. We can click here on this three-dot icon and get the all pconfig variables, which will fetch the configuration details directly from the petrol agent. Once you click on execute, you'll get the output. Now here you can see this deny CFG parameter that we spoke about earlier. The value default is set to false, which means TSPS can configure this petrol agent. Then you can also see what config data has been pushed on the petrol agent and what are the other KM configurations that has been pushed from this monitoring policy to this petrol agent. Then there are some other commands that you can use to verify and retrieve the configuration directly from the petrol agent. Another method to confirm the configuration data has been pushed to petrol agent and if the petrol agent has started the data collection or not is to use the dump hist command. You can run the command dump_hist and export the output to a particular file, and you can then view the file to confirm for what monitors the data collection has been started. Since we have pushed the monitoring data for the Windows monitoring, I can see the Windows monitoring data collection has been now started. This confirms that the petrol agent has started collecting the data, which means the monitoring policy has been successfully applied on this petrol agent. Only if we see the petrol agent has started collecting data for its monitoring solution, then it will forward the data to the TrueSight Infrastructure Management Server via integration service, which will then be fed in the TrueSight Presentation Server. If you don't see the data at petrol agent itself, this would mean either policy configuration is not correct or the policy has not been applied successfully on this petrol. From here, we can confirm that the data collection has started for these petrol agent. These are the few easy checks that anyone can perform after creating the infrastructure policy and verify it has been applied successfully or not. This concludes the demo for the monitoring policy verification. Now let us move ahead to understand what type of logging can be enabled or can be reviewed in case of any failure. Since the infrastructure policies are created on TSPS, CMA is the component that is responsible for this policy to be created or applied. We will first turn on the debug on TSPS server for CMA component as mentioned here. This command is same irrespective of the operating system on which the TSPS is installed, like if it's on Windows or Linux. Debug could be enabled using the command tssh logger debug on -n CMA. Once the debug is enabled, you need to create or edit and save the policy for the information to be written in the TSPS log files. After you save the policy, the debug could be then disabled using the command tssh logger debug of -n CMA. The created log files are stored on the TrueSight Presentation Server and written in the log file named cma.log under Installation Directory TrueSight Server in Logs folder. Along with cma.log, default TrueSight.log would also have some details that can be helpful to review and analyze the failure. This configuration is further pushed to TSIM and integration service. There would be a very rare scenario where debug logs need to be reviewed on the integration service. As if the petrol agent is connected, it would just receive the configuration information and forward it further to petrol agents. So the next failure, mostly if it can happen, would be either petrol agent or its monitoring solutions. If we see the configuration policy is applied on petrol agent from TSPS, however, we don't see the petrol agent collecting data as per the configuration applied, then we would need to enable the petrol agent debug or its KM debug. One can enable the petrol agent debug on Windows environment by editing the petrol agent service and adding the -debug option in the starter parameters of that petrol agent service and then starting the petrol agent. As we saw in TSPS debugging, after enabling the debug on petrol agent, we need to reapply the configuration from TSPS by saving the policy again, so that it can write some information in the petrol agent debug log file as well. Do not forget to disable the petrol agent debug by editing the petrol agent service and removing the startup parameter options. You might want to enable monitoring solution debug, that is KM debug, in specific scenarios where the policy is getting applied and we can see the configuration variable being pushed on petrol agent. However, you don't see either the data collection have started specific to that KM. There can be a scenario where you need credentials or authentication for specific KM configuration. If the correct information is missing in the policy configuration, this can be written in the KM debug logs. Most of the KM's debug can be enabled while configuring the policy from TrueSight console, where it has a debug checkbox to be selected to enable KM debug. Do not forget to create the monitoring policy after the debugs have been enabled, and also disable the debugs after you have collected all the required log files. You can raise a support case for complex scenarios and support team can assist you further. We will now look at some of the log messages with regards to CMA infrastructure policy. We will go through the complete working log scenario to understand how this configuration is pushed. As soon as we click on the Save Policy in TrueSight console, it writes into the file with keyword CMA preparing to save policy. This line would contain the policy name in brackets. The followed by lines will provide details what has been mentioned in the policy, like the agent selection criteria will be written in the line, starting with CMA rule specific condition. This will then create a function for the condition specified in the policy and will be saved in TrueSight Presentation Server database as well. Depending on the list of the petrol agents that meet the agent selection criteria, CMA will create and show the list of all the petrol agents on which the policy will be applied. This list has the petrol agent name followed by the TSIM server component ID and the integration service agent ID. Here in this snippet, we can see 10007 is the integration service agent ID, which can be verified using pw remote list command output on TSIM server. And 4 is the component ID of the TSIM server that can be retrieved from TSSH component list output. In case if you don't find your petrol agent name here, this would confirm that the petrol agent does not meet the agent selection criteria in the policy, and you might want to verify and correct that. In case of any failure, we can see an error like unable to get list of petrol agents associated to policy or something like failed to get list of petrol agents associated with the policy. In this case, you might want to check if the user who created the policy exists or not. If until here we see all is good, then the next line shows CMA policies applied on petrol agent. This line confirms policy is applied on the list of the petrol agents. In case of any failure, it would say CMA policy failed to apply on petrol agent. Then we would need to verify the communication between the components is working or not. One of the exception in the log can be unable to send config resync command. This could be due to a socket error, where restart of TSPS can help fix the socket error between the components. Then, followed by these lines in the log file, if the policy is applied, then it would write the line saying what configuration data will be pushed and on what petrol agents. This will be in the line starting with CMA sending data to PA. This line would give the list of the petrol agents on which the policy will be applied, followed by the configuration data that will be pushed on petrol agents. You can also review this to understand what information is being pushed on petrol agents. In this log snippet, we can see if any server-side configuration is pushed on TSOM server. Then it would be written with server-side operation and server-side action, providing the details as what configuration is pushed to TSOM from this policy. The last line of this transaction would be CMA configuration applied successfully on petrol agent. This completes the application of the petrol agent. As we saw, this log file confirmed that the policy is applied from TSPS server. However, if configuration is pushed further on petrol agent and functionality has not been enabled, then we would need to review further the petrol agent debug logs or the KM debug logs as we discussed earlier. Any misconfiguration pointers can be plotted in the KM debugs. We will now have a look at a demo for debug logging. This is my TSPS server. From the command line window, we can enable the debug on the CMA component with this command. Now, as the debug is enabled, we will need to enable the policy so that we can see the flow in the logs. This is the TrueSight console. Let's click on Infrastructure Policy and enable our policy. In this demo, I will enable the lightweight protocol monitoring for ping and port devices. Let's enable the ping devices. I have created a file on this petrol agent and have added the ping devices. And we have also enabled the port monitoring here on this device for 3181 port. I have also made a configuration for these devices to be added in the group called ping devices from server tab. Let's enable the policy now and click on the save button. Once the policy is saved, we can now go and disable the debug using off option. We can see the cma.log is updated under TrueSight pserver logs folder. Let's open this file. You can find CMA preparing to save policy with this policy name. As we discussed earlier, we can see the criteria on which petrol agent this policy will be applied. We can see here this policy is applied on this server where LWPKM is installed. We can see this configuration data related to LWPKM starts with ppm, which is being added to the list with this attribute pconfig data. Then once that data is processed, we can see CMA policies applied on that petrol agent since there was no error. And we can see sending data to the petrol agent, and here we can see in this line what all configuration data will be pushed on the petrol agent. Then further, if we scroll down, we can see the server-side operation response object to be sent, as we had added this devices in the group called ping devices. So we can see this configuration being pushed on the TSIM server. Then we get an acknowledgement from the server-side configuration, and we can see this instances will be added in the group called ping devices. From this log, we can see the policy was successfully applied on the TSPS server. Now let's see on the TrueSight console and find out if the monitoring is enabled for the ping and port monitoring. As we can see, we have enabled the ping and port for these devices. However, you'll see only ping monitoring is enabled right now. Let's launch the graph of this, and we can see the monitoring has been started. And we can see the data availability of this server is 0. If you see, the port monitoring was not enabled. So let's see in the infrastructure policy and find out why the port monitoring is not enabled. We can see from the logs that the policy was successfully applied and there were no errors. In this case, we can enable this logging here to enable the KM side logging to understand what could be missing in this policy, due to which this policy was not applied. In this, if you see, this Java path is blank. Port monitoring requires the Java to be installed on the petrol agent, as it needs the JRE to enable the port monitoring. So if you enable this logging, we will get some message in the KM debug log on the petrol agent. You can click on OK and save this policy once. I have logged into the petrol agent. For LWP KM port monitoring, the folder name is PIM. Under PIM, we will see the logs folder, and under agent, we can see the debug has been enabled and it is writing in the log file. And we can see some messages related Java being not found on this server, due to which the monitoring for port is not being enabled. So this gives a clue why the port monitoring was not enabled, even though we can see that the port monitoring policy was applied on this petrol agent. This concludes my demo for debug logging. We will now go through some of the best practices that should be considered while creating and deploying infrastructure policies. Let's first start from petrol agent side configuration that should be considered. Let's talk about configuration variables, disabled KMs, and preloaded KMs. Disabled KMs prevents KM from being loaded by disabling the monitoring of unwanted KML or application classes defined in this variable. Preloaded KMs would be used to load the KML for which monitoring policies are enabled. Now there can be some KM, for an example, custom KM that is not configured from TSPS policy, and you might want them to be preloaded. You can thus use this variable preloaded KMs to add the KML files in the configuration using pconfig utility. Configuration policies never use agent setup disabled KMs variable unless added for agent tuning. If the policy is disabled or the agent is not part of agent selection criteria, then agent will just keep running with previous old pconfig configuration rules. Or if for some reason you have to purge the petrol agent configuration, then it flushes the pconfig database, removing the disabled KM variable. All KMs are then loaded, thus creating huge number of instances in the TrueSight. To avoid such issues on purge, you can create a .current file on petrol agent. Agent loads the configuration variables from the .current files prior to full run mode. Now we will have a look at some best practice that includes the configuration on TSPS policy. To start with, as discussed earlier, using staging policy in large infrastructure environments would be very useful. If the petrol agent connects to a staging IS, it will remain dormant until a staging integration service policy has been applied on it. This can help you configure and verify the newly deployed petrol agent's communication in pre-prod before getting the monitoring enabled in production environment. Do not enable policies for production petrol agents until tested. Then another best practice related to infrastructure policy would be establish a naming convention and policy precedence scheme before you begin creating the policies. It is very important to keep policies organized, otherwise it can be difficult to know the configurations that are applied to agents and the order in which the precedence is applied. While defining the configuration of the policy for a particular instance, for an example Windows service, then one should use the display name instead of the service name, as that would be more meaningful to understand which service is down when alarm is generated for that instance. Now let's see some best practices around monitoring configuration. One should carefully configure the monitoring policy and should be very specific so that it does not create unnecessary monitors for which monitoring is not required. Utilizing Linux default and basic health with all monitor type may add many monitoring instances that you don't need. So review the monitors that would be added and enable the monitoring only for the required monitor types. Utilize base health configurations and add on as required. Do not mix infrastructure configuration settings and monitoring configuration in the same policy. Keeping them separate helps you keep policies better organized. And in most environments, it reduces the number of places in which you have to manage the infrastructure configuration settings. Also, avoid any duplications on the policies and agent configurations. Now let's see some best practice of configuration variables. Remember, do not configure any critical configuration on petrol agent from policy. For an example, if you push the integration service name variable from a monitoring policy, and for any reason, if you disable this policy, then this configuration variable will be removed from the petrol agent configuration, causing the petrol agent to be disconnected with its IS. As disabling the policy would cause the petrol agent to go back to its default, and if that pconfig variable was blank initially, then you would not be able to connect to it from TSOM again. Another example of why good practice to use .current file. You can use configuration variables for some tuning parameters or something that cannot be configured via policy. Now, TrueSight Operations Management has its own troubleshooting section in the documents. Purpose or goal of this troubleshooting guides is to understand, identify, and self-solve. And in the event you're not able to self-solve, then you'll already have the items and data needed to open a better support case. As highlighted on this TrueSight page, you can see the troubleshooting section is located in the top level of the navigation pane, as well as the link highlighted on the bottom right of the screen. There is a specific page with title Troubleshooting Monitoring Policies that would contain some troubleshooting steps related to the policies not getting applied. Reference slide has a link for the same. Now let's have a look at some common issues seen while applying the infrastructure policies. In case if you see an issue, monitoring policies are not getting applied to new petrol agents, then you can have a look at the CMA logs on TSPS server. If you see an error like fail to get list of petrol agents associated with policy, in this scenario, there could be an issue, maybe either the user that created or owned this policy had been deleted, or the policy owned by that user were not shared with the group and is no longer usable. You can recreate the same local user in Remedy Single Sign-On, that is RSSO, and then log in with the same user. Then edit those policies to be shared with the desired group. As a result, the policies will now be applied as expected, and all the members of the defined group will be able to modify the policy as well. This is documented in KA number 364167. We have also seen a common issue where CMA policies were not applied on any petrol agent, and one of the messages shown in this slide could be found in the CMA.log. This can happen if the security policy registry keys are missing on TSPS where CMA component resides. In this case, you can go to the TSPS server in the mentioned location, TrueSight P server module CMA pproxy PNS security, and import the registry by double-clicking on pns.rec file and restart the TSPS server. Now, latest health check tool report would also notify if registry keys are missing on the TSPS server. Well, this does not apply on 11.303 and higher versions, as from 11.303 onwards, TSPS will automatically add the registry key if found to be missing. This is documented in Knowledge Article 356862. There can be a scenario where policy fails to get applied on petrol agents due to mismatch of KM version. In such a case, you would see the error in the TrueSight.log file with the message unable to process AL due to KM is non-compatible. The error indicates that the KM version might be older and it cannot be configured via TrueSight Presentation Server. To fix this, you can upgrade the KM on petrol agent to match the repository KM version. Reference knowledge article for this is 237739. Now, in most of the scenarios we have seen, server thresholds not getting applied on TSIM server via monitoring policy. Most common reason for this is the monitor instance name is not specified correctly while configuring the policy. In CMA.log, you would clearly see a message, exception while handling threshold response. This would confirm the regex pattern or the instance name is not correct. You can follow the document to understand the regex pattern usage, and few syntax examples are mentioned in KA237739. You need to be sure there is no other policy or another configuration with incorrect instance name being applied on same device, as even if the configuration is correct here but not correct on the other policy, it will restrict the configuration being applied on that device. If instance name has a bracket, then you need to use escape character for both open and closed parentheses if you need to mention the brackets in the instance name. Or you can use dot star. It would mean it contains any character or characters in between. If you have to associate a device name with the instance name, then the syntax would be device name / instance name. This reference slide has links for configuration, best practice, and troubleshooting infrastructure policies. It contains some additional information about what has been covered in this webinar. There is also the link for the petrol agent installation best practices. In summary, we covered the overview and flow of infrastructure policies by understanding the related architecture of the components involved in the functionality. For configuration, we looked at the key configurations that can be considered while deploying the infrastructure monitoring, some key configuration that needs to be configured correctly for avoiding any issues or can be considered in planning for better understanding of the monitoring even after the deployment is done. In this webinar, we also saw staging policy concept, how it can be effective for deployments of new petrol agents in production environment. We saw some use cases that explains the policy precedence behavior. Then the key parameters were included in the slides explaining the importance of their configurations. We did some basic level of logging that can be done to fix some known issues if any. Some of the common support issues that customers have faced were covered along with the best practices. And that concludes my presentation, so I will hand you back over to Greg.
Thank you. And now I'll take us through the self-help in contacting BMC. The YouTube channel where this webinar will be posted is available at this link. It contains past webinars as well as a rich set of how-to videos. The Connect with TrueSight webinar schedule that contains future webinars as well as our past webinars is available at this communities link. Also, the Hot Off the Press newsletter contains trending information. And to contact technical support via web, phone, email, as well as these social channels are available through these links. That will conclude our session today. Thank you for attending.